Good afternoon. Today we'll see one more example we'll solve using the branch and bound method. Let us consider the problem. Max z is equal to 8x1 plus 5x2 subjected to the constraints 9x1 plus 5x2 is less than or equal to 45. x1 plus x2 is less than or equal to 6. x1 comma x2 is greater than or equal to 0 and integers. Now we have to solve this using the branch and bound method. So as I used to do, I'll just divide this into three parts. This is to draw the graph. This is to write the decisions or the tree or the bounds. Now, first we'll solve the first equation, and to solve the first equation we'll be considering this is equal. So, 9x1 plus 5x2 is equal to 45. Let consider any one of the variable here equal to 0 so that we will get the value of other variable. Let consider x1 equal to 0, x2 will be 45 by 5. You will get 9. So the first point is 0, 9. Let consider the second point. Let x2 equal to 0. If x2 equal to 0, then x1 will be 9x1 will be equal to 45. Therefore, x1 becomes 45 by 9. You will get 5 here. So the next point here is x1 is 5, x2 is 0. 5, 0. I draw the graph here. This is x1, this is x2. Okay, so here 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12, 14. Our first point for this particular equation is 0, 9. x1 is 0 and the x2 is 9. Then the second point is 5, 0. So around here 5, 0. So join this point like this. And what is the constraint here? This should be less than. So what is the feasible region? It should be within this. Now we'll solve the second equation. x1 plus x2 equal to 6. Okay, I'll solve here. x1 plus x2 equal to 6. So as we used to do, let consider x1 equal to 0. If x1 is 0, x2 will be equal to 6. So the first point is 0, 6. Then let consider x2 equal to 0, then x1 will be equal to 6. 6, 0. This is our second point from the second equation. So just to draw this, 0, 6 is here, 6, 0 is here. So join this like this. Again, what is the constraint here? Less than. So your value will be within this. Now, what is the feasible region? Feasible region is, these are our feasible regions. Our value, optimal value, resides within this region. Like this. Okay, you can draw this in the graph sheet. So what are the points here? This point is 0, comma 6, and here this is 0, comma 0, and here this point is 5, comma 0. We have to find out the value for this. Okay, in the graph sheet you can directly find out. Otherwise, how we will get to this? This point we got from the intersection of first equation as well as the second equations. So, solve the first and the second equation to get this, the value of this point. So, solve this. And this becomes 9x1 plus 5x2 equal to 45. So, I will multiply with 9 here. You will get 9x1 plus 9x2 equal to 6. So, you will get 48. Correct? So, if you subtract here, you will get 3x2 equal to 3. So, x2 will be equal to 1. x2 will be equal to 1. Cut the children. Multiply here with 9. So, you will get 9x1 plus 9x2, 54. 9 6 are 54. So, solve this one. You will get minus 4x2 equal to 45 minus 54. So, you will get minus 9. So, x2 equal to 9 by 4. You will get 2.25. Correct? x2 will be equal to 2.25. Substitute to any one of this equation, you will get x1 value. So, for example, if I substitute to this equation, you will get x1 plus x2 equal to 6. Substitute this x2 value here. So, x1 equal to 6 minus 2.25. x1 equal to, you will get 3.75. So, this point indicates 3.75, 2.25. Now, from this we got this point, this point, this point. Find the maximum value for z. So, z value, if you substitute x1 value here equal to 0, x2 equal to 6 here, 5 6 are. So, you will get 30 here, z value is the 30 here. If you substitute x1 and x2 value, you will get here 40, and z value, if you substitute here 3.75 and 2.25, you will get 41.25. So, we'll be considering, among this, we'll be considering this point as it gives us the maximum value for our z. So, I'll just write here z is equal to 41.25, x1 is equal to 3.75, x2 equal to 2.25. Okay. So, now can we stop here? No, because these are not integers. So, to convert this into integers, branch this. Whether to branch this x1 or x2, select the maximum. So, x1 is maximum here. So, branch this. This value 3.75 lies between 3 and 4. So, this value lies between 3 and 4. So, this is the value of x1. So, just add and constraint here. x1 is less than or equal to 3. x1 is greater than or equal to 4. Now, along with these two, include these two constraints and try to solve this problem again. I'll include this constraints here. This is our objective functions with constraints. Now the new one I have to include here is x1 is less than or equal to 3. So here I'll write again 9x1 plus 5x2 is less than or equal to 45. x1 plus x2 is less than or equal to 6. x1 is, now I have to include this constraints 4. Okay. Now what are all the points we got from here? From this equation we got 0, 9, 5, 0. From this equation we got 0, 6, 6, 0. From this equation we got x1 equal to 3. From this equation we got x1 equal to 4. Okay. So here from this equation the points are 0, 9, 5, 0. From this equation 0, 6, 6, 0. Now we will draw the graph. So draw the graph here. 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 14. This is our x2, this is our x1. So this is our x2, this is x1. So 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. Now 0, 9. So 0, 9 is here. 5, 0. 5, 0 is this point. 0, 9, 5, 0. Draw this. Then 0, 6, 6, 0. 0, 6, 6, 0. So draw this point. Okay. x1 is equal to 3. x1 is equal to 3. Equal to 3 indicates it's parallel to your one more axis. So x1 is equal to 3. And what is the constraint? It should be less than. So your feasible region is within this. Okay. And here x1 is equal to 4. It is x1 axis is equal to 4. So you will get like this. And what is the condition? It should be greater than. Greater than indicates away from the origin. So the value should be here. Now we'll try to find out the values. See here, what is the feasible region? Feasible region is, these are our feasible region. So these points are might be somewhere here. The values are called values will set into our objective function as well as all these constraints. So these are our feasible region. And here, see, it says it should be less than here. Value should be here, but the last constraint says that it should be greater than. So you will get only here the coinciding point here. Okay, only one point. There is no feasible region. You will get only one coinciding point here. Here we will get, see, this one point here is 0, 6. Here is 3, 0. Okay, and here to get to this point, what you have to, which two equations you have to solve? You have to solve two intersecting equations. So in this case, see, this indicates x1 is 3. So very clear, x1 we got 3. And which is this line represents here. this line represents here. This is actually this, the equation number 2. So you will get here the value equal to, one is 3 and one more is x1 plus x2 equal to 6. So x2 will be equal to 3. So 3 comma 3. This is one more point. Now the maximum value for z, 0 comma 6, maximum value for z is 30, and here maximum value for z is 39 and maximum value for z is 24. So 30, 24 and 39. So maximum among this is this value we have to consider. Now let us consider the second part here. We have got here only this intersecting point. So we have to consider this point. So what is the value of this point? To find out the value for this point. See, it's very clear that one line is this one. So what is the value? x1 is equal to 4. So very clear that this value, x1 value is 4. What is x2 value? To find out, you can see either you can solve this or you can solve this. Suppose if I substitute this x1 value here, 9 into x1 plus 5x2 equal to 45. Substitute this x1 value here, x2 will be equal to, you will get 1.8. So 4 comma 1.8. So just substitute this x1 and x2 value in the objective functions, you will get f is equal to 41. Now, suppose if I consider x1 is less than or equal to 3, what are all my points? 0, 6, z value is 30, 3, 3, z value is 39, and 3, 0, z value is 24. So which is maximum here? 3, 3 and z value is 39. If I consider x1 is less than or equal to 3. So z value equal to 39. x1 is 3, x2 is 3. Both are integers. Now, if I consider this constraints, x is greater than or equal to 4, what is the objective function f? Or we have indicated here it as z, so we can represent it as z. If I go for this constraints, then z value equal to 41, x1 value equal to 4, x2 value equal to 1.8. See, here compared to this, I have got here maximum value for the objective function. So if I proceed in this, might be I may get the maximum optimal value for z, and both the x1 and x2 values may be integers. So I will try to forward in this path also. So here if I consider x2 is in decimal. So I will divide again this as x2 value, it lies between 1 and it lies between the integer 2. So just I will add the constraint here, x2 is less than or equal to 1 and x2 is greater than or equal to 2. So let us again consider this constraint. I will add here, this constraint I will add here for the constraint x1 is greater than or equal to 4, and will further proceed. Now we will try to include this constraint here. So here one more constraint now is, say this one, so next it leads to this. So this x1 is greater than or equal to 4, x1 is greater than or equal to 4. Now we are in this direction wherein x2 is less than or equal to 1, x2 is greater than or equal to 2. Two cases also we have to consider here. Now let us again solve this equation. So these are the values will remain same, and here x1 will be equal to 4, x2 will be equal to 1. And here x2 will be equal to 2. We will see which gives us the maximum optimal value for this z. Again solve this equation. So here 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12. x2, this is x1. So again here 2, 4, 6, 8, 10. x1, 2, 4, 6, 8, 10. Again x2. 0, 9 and 0, 9 and 5, 0. Join this. Here also join this. Second point is 0, 6, 6, 0. So 6 and 6, 6. Join this. Join this. Okay. Then x1 is equal to 4. x1 is equal to 4. It indicates we have to draw a line parallel to this y-axis. So x1 is equal to 4. Here x2 should be, this x2 should be less than or equal to 1. x2 should be less than or equal to 1. Okay. Now less. So the direction is like this. All these directions are all here less than. And x1 says here, this x1 says the value should be greater than. So we have to consider this part and all which comes under this. See, this comes under this, this comes under this, this comes under this. So you will get only this portion as a feasible region. So you will get almost this portion as a feasible region. So you have to find out the value for this. So that's the reason if you draw neatly in the graph sheet, you will get the points properly. Then if I go for this, first we'll try to find out the values. So you will get here, see this is anyhow 4, 0, z value will be equal to 32. And this point will be 4, 2, z value will be equal to 42. This region is 4.4, 1, z value will be 40.2. And this will be 5, 0, z value will be 32. Okay. Now, so if I consider this, x1 is greater than or equal to 4. x1 is this point. So x1 is greater than or equal to 4. It should be greater than. x2 is should be again greater than or equal to 4. So again if you consider, see this constraint says it should be less, it should be less, it should be less. So you will get just one coinciding point here. So find out the value of this one. You will get 4, and here it is 2. And z value you will get here 42. Okay. Now we will see which one to consider. See, if I consider here 4, 2 value is 42. But initially what should be the value of z here? 41.25. So we will be considering this as a infeasible solution. Then this point if I consider here, you will get z is equal to 40.2. If I consider this, you will get 32. If I consider this, you will get 32. So which is among these three, which gives you maximum optimal solution for z? Z you will get 40.2. So if I consider this equation, x2 is less than 1 here, you will get z is equal to 40.2, x1 is equal to 4.4, x2 is equal to 1. Okay. Now if I consider this, you will get only 1 point. If I consider, go for x2 is greater than or equal to 2. 1 point. And what is the optimal solution here? 42. So if you compare with the first one, it should be always less than or equal to 41.25. So again this will be considered as a infeasible solution. So I cannot go for this because which gives me infeasible solution. Infeasible solution. Okay. Next, again here 40.2, it is not integer, so it says still you can proceed like this, like this, like this. You can still proceed to the next iteration. So what is x1 value? 4.4. So I will divide now because x2 is integer, so I will just go for x1. So x1 lies between 4 and 5. Okay. Now what is the constraints you have to add here? X1 is less than or equal to 4, x1 is greater than or equal to 5. Include these two constraints in this along with this equation. We'll see how exactly it works. Consider this constraints: x1 is less than or equal to 4, x2 is greater than or equal to 5, and we'll try to solve this. So the first point is 0, 9, 50. So 0, 9 and 5, 0. So join this 0, 9, 5, 0. So join this. Okay. Second point is 0, 6, 6, 0. 0, 6, 6, 0. 0, 6, 6, 0. 0, 6, 6, 0. So join this. Then x1 is greater than or equal to 4. x1 is less than or equal to 4. We have both the constraints here. So let us consider this as x1 is equal to 4. Okay. So x1 is equal to 4. So this is one more point. Then x2 is less than or equal to 1. x2 is, so this is one more point. x2 is less than or equal to 1. So what are all the points now? See, here this should be x2 should be equal. So this should be equal, and if you observe here x1, these are all lesser. It should be within this region. So these are all feasible, and x2 should be less than. So it should be within this, and moreover x1 is equal to 4. x1 is equal to 4 indicates we will get only this point as a feasible region. So what is the value for this? You will get x1 is equal to 4 and x2 is equal to 1. 4 and 1. What is the z value? Z value is equal to 37. Next we will solve this one. So here x1 is equal to 4. x1 is equal to 4. So you will get this. x1 is equal to 4. You get this. Then x2 is equal to 1. So x2 is equal to 1. x1 is equal to 5. Again I am saying x1 is this one, is equal to 5. So one more line here. So now we'll just include, just see all the constraints. See, these should be less than or less than. So our value resides within this region. Okay. x1 is greater than. x1 is greater than. It should be away from the origin. It should be greater than. x2 is less than. So it should be within this. Okay. x1 is greater than 5. Again it is greater than 5. So if you observe here, see our intersection point is here and here, and it should be greater than, x2 is greater than 4 and greater than 5. So it should be here, and our value should be equal to. So greater than and equal to, and it should be within this. So we will get only one point here like this. So value of this will be 5, 0. I hope you understood. It should be greater than and it should be within this. So you will get this region. So what is the value of this? So z value you will get 40. Okay. Now we'll consider If I consider x1 is less than or equal to 4, I will get only this point. So this point is z is equal to 37, x1 is 4, x2 is 1. And if I consider this constraint, so here z is equal to 40, x1 is 5, x2 is 0. Okay, now we'll see which one to consider. See, this is our integer, so we can consider this. This is our integer, we can consider this. These are decimal, no. These are decimal, no. This is our integer, we can consider this case. So consider now all the cases. See, z value is 39, z value is 37, z value is 40, and these three are integers. So which gives us actually maximum, so optimal solution within the feasible region. This gives us maximum optimal solution. So final answer is, we'll be considering x1 is equal to 5, x2 equal to 0, z is equal to 40 as the answer. See, these three are also answer, but which gives maximum optimal solution. This gives, these 2 points gives us maximum optimal solution. x1 is equal to 5, x2 is equal to 0, z is equal to 40, and it is within this also. So this is our final answer. Thank you.
Reva University, one association for many great careers.